fundamental concepts of computer science, where we're going to learn how to convert. Now, we have been learning how to convert things to a decimal, but now we're going to learn how to convert from decimal to other things. So now we're going backwards. And if you kind of recap from the previous video, where we were either doing the 2 to the power, like either looking at the base 2 to the power 0 up to infinity, or the 8, maybe the 8 instead of the 2, or the 16 instead of the 2 and 8, right? So this time, because now we're not going to a decimal, we will be learning how to divide and looking at this other table that I don't have a picture form of yet. So basically, let me check. Tonight, we're going to learn how to convert from decimal, or let me go with the bases. So we're going from base maybe 10 to base 2. Then we can also go from let me see, base 10 to base 8. Then we're going from base 10 again to your base 16. And then on the other video, or on the next video, we're going to look at how we can go from either of these bases. Okay, so basically this is cos 1521. Yeah. Okay, let's listen again. But I am gonna write the name of it in the description box once the video is out. So you're going to go and take a look at page 29, right? At page 29, where we're going to learn how to do the whole division, or how to convert from a decimal to another number system. Okay, so suppose you have a decimal number 25. So let's say you're given 25 and then in the base 10, and then you want to convert it back to binary, right? So you want to know how the computer actually does this for you. So you want to go to a base 2 number. The diagram, basically, if you look at it, is basically teaching you the general method. So the general method is to keep dividing by the destination base and record the remainders. So the source in this case is the number that you start with. So 25 base 10 is the source, right? And then the destination is the answer that we're building. So if you, let me write destination is the binary number. So we want our final answer to be in binary. So as you can see, last time when we were talking about the software in the outcomes, I said to you, whenever you want to solve something, you basically have to kind of build what your answer should look like. So you have to visualize your scenario, and this table helps us visualize what our answer should look like. And yeah, so like I said, 25 is the source. The destination is a binary that we're going to. Obviously, if you were going to an octal, the destination would be an octal, and so as to for the hexadecimal, right? The base, in this case, the base of the destination would be 2, or the base that we are converting to is 2. And then, okay, now let's start. So we had 25, 10 to a binary. I think I spelled that incorrectly. Binary, which is a base 2. Okay. So step 1 is to divide the source by the base. So 25 divided by 2, so the destination base, right? And that is 12 remainder 1. And then step 2 is to insert the remainder at the left of the destination, which would be 1. So at the left. So the 1 basically goes here. Yeah? And then we would build the answer from right to left. So we're going to go right to left. The answers, every remainder that we get, we're adding it like that. So if we get 0 in the next answer and 1 can be 2 because we're going binary. Let's say you're having things like this, your answer is basically going to go that way instead of this way. So we wouldn't be writing the rest of the remainders here, but they would come this side. Okay. Okay. Step three is to take the new quotient, which now becomes the new source. If you look at this, our new quotient was 12. So now it's going to become our new source. Then we're going to divide it by the destination base. So let me do it here. So you're going to have 12 divided by 2, which this is 6, remainder 0. So even if your remainder is 0, you still have to type it in. So I'm going to add in the 0 here. And then we look at our new quotients, which is now step 4. We're going to repeat the same thing. So we have 6 divided by 2, which is 3, the remainder 0. Then you repeat. So you take the 0, you insert it there. So you're basically inserting the remainder to the left, right? To the left of the last remainder, if you understand what I'm saying. And then if you repeat, you'd have 3 divided by 2, which this is 1 remainder, 1. And now you would have a 1 there. And then if you think of repeating, you'd have 1 divided by 2, which is 0, remainder 1. Then you plug in the 1 here again, right? And so this would be what your final answer is. Because if you think about this, if you have again 0 divided by 2, what are you getting? You're getting 0, or yeah, 0 just remainder 0. You do it again, 0 divided by 2, which you'd keep getting this answer. And remember what I said, well, with regards to the outcomes. 0 always means off state. So this is the off state. The computer ignores it because nothing here actually matters. So we stop at the 0. So I'm gonna explain step 9 to you. So step 9 is to check the condition. The diamond in the diagram basically asks you, is the quotient 0? And in step 8, which is this step, you see that the quotient is 0, so you basically stop. Okay, so that means stop, you're done, your final answer is built. So that means 25 in base 10 is equal to 1, 1, 0, I think it was 0, 1, and you show that with a subscript 2. I hope you understand what I'm saying. So you might ask yourself, if you look at the diagram, I don't have the diagram with me, so I don't know what to copy. So let's say this is the diagram, right? And then it has an arrow going back like that. So if you look at this diagram that I drew, you might ask yourself, why does it keep moving? Okay, and you notice this arrow keeps going back, So this arrow is going back like that. And that's because the process actually repeats. If you look at what we did, we kept on repeating. Uh, um, we divided the quotients, the new quotients became the new source, and then we kept on recording the remainders. So um, the process basically keeps repeating or keeps looping. And yeah, in programming one, you'd call this a loop. So the flow chart here is basically saying, while the quotient is not zero, divide by the destination base, store the remainder, and then use the quotient as the new source, right? Up until you get to, let's say there's a diamond here. Um, that's a diamond. So let's say this is a diamond. This diamond is actually the condition that says, that asks you, is the quotient zero? If not, you continue. And so you would move back to this point and do the same thing. You get here to this diamond. It asks you, is it zero? It says no. You keep going back. So when you're calculating using your calculator, this is basically what's happening behind the scenes, and you get the answer straight away because it's been programmed, right? Hence, programming is the art. So basically, yeah, the flowchart is an algorithm or a problem that you solve. So let's try to convert 35 base 10 to a binary, which is 2. So take notes of how we are answering. So here you would have 35 divided by 2. This is 17, remainder 1. If you want to, you can just quickly store in your remainders here, right? And then you would have 17 divided by 2, and that is 8, remainder 1. And then you store in the 1 again. And then you have 8 divided by 2, that is 4, remainder 0. So you take that, you store it, then you go, and that is 2. It's supposed to be a 2 there. So now you can go on to this and say 35 base 10 is equal to, because they are actually equal. So 35 base 10 is indeed equal to 1, 0, 0, 0, 1. So you can close that in brackets if you want to. And that's your final answer. So I'm just going to try the last one, and then I'm going to give you 2 examples to try. Okay. Okay. So let's say you have what, to convert 126 in base 10 to binary. So please do take note of the steps that are being implemented here. This is how you should indeed answer. So you would have 126 divided by 2, and that is and that basically tells you that you're done. So now you're going to want to store in your numbers. So you have 0 from the right, you have 1, 2, 3, 4, 5, 6 ones, and that's in 2, right? So those are your numbers or the final answer. Okay, can you try to convert? So convert 128, 10 to binary. And then also, let me see, didn't leave you guys with so many examples, but okay, try 124, 10 to binary, and then try 61. Yeah, I think that's quite simple. Obviously, you do have to learn your long division. So if here you have 128 and you're dividing by 2, you basically do the whole process of 2 times, sorry, 2 into 12 first, and then you plug in the 6, and then you go 6 times 2, you say 12, sorry, 12, and you subtract, and then your answer is 0, bring down the 8, then you do the same thing, 2 into 8, you get 4, 2 times 4 is 8, you subtract, and your answer would be 0. You keep basically doing the same thing, okay? And obviously your answer would then here be 64. And because this is your number 1, that means the answer that you get here would be to the left. So do you record that this is number 1 and then you start the other one? You would basically start with the 64 divided by 2, and then you record that this is number 2 to know how to record your remainders. In the next video, we are going to do things like long division methods, yes, so that we don't find ourselves lacking. For now, we're not gonna look at things that have to do with fractions because I'm saving that basically for the last video. But for now, let's convert things to hexadecimal. Right? And obviously, for you to be able to do this, you do kind of have to know your long divisions. So I'm just going to move quickly to long divisions because there is a video that has to do with long division. So if we are given 1411 in the base 10 and asked to convert it to hexadecimal, you do have to quite remember what the hexadecimal system looks like, so that you don't get confused with your alphabets, okay? Um, so, yes. So what you do in this case would be, so what you're going to do is you go like that, you write the first thing that was given to you, which is a source, the destination base, and then you're going to label this as 1, right? So you check how many times does maybe 16 go into 14, you check it's 0. So you say 16 times 0, that is 0. So 14 minus 0 is 14, going over the 1. So I should have just did the 141 instead. Then you ask yourself again, how many times does that go into that? It's 121. Then you you basically ask yourself, oh, so you cancel out. So 141 is 13. And then you do the whole process again. I just have to go down. So let me do it again. So you do the whole process again, give a 0. All right. So now what you're going to do is go from number 1. 3 is always 3, 8 is 8, and 5 is 5. So our answer is 3. Our answer is it's gonna go obviously from the left. So we're gonna go 385 to the decimal. So base to the hexadecimal, sorry. So 1411 10 is equal to 3 8 5 16. Hope you understand. So I'm just gonna do one last example, and then I'm gonna leave you with some to try on your own. So let's say we given 5 6 7 10, and we are asked to convert it to the base 16. Right, okay, so I'm just gonna have things like that. So for number 1, we have what is given to you, 5 6 7, and the 16. Ask yourself how many times does 16 go into 56, and it's 3 times, so that's 48. You also bring down the 7, you cancel this side, and then 56 minus 48 is 8, I think. And then you ask, you bring down the 7, ask how many times does 16 go into 87? That's 5 times, and that's 80, and that's 7, right? So in your next step, you would have now 35, 16, which is step 2, right? How many times are 16 going to 35? It actually goes 2 times, which is 32. Subtract, then you have a 3. And then for the last step, you have 2, 16. How many times is 16 going to 2? 0 times. Once you have a 0 here on top, that means you are done. So 0 times 16 is 0. Almost sure it's 16. And that's 2. So this is how basically your answer looks. It's 732, meaning 5 6 7 10 is the same as 7 3 2 and the 16. Hope you get what we are doing. So I'm just going to leave you with an example to try on your own. So if you were given 2, 1, 2, 6, 10, and asked to convert it to the base 1, 6, and then you're given 4, 1, 8, 10 to base 16, and then also, let me see, 2, 2, 8, 10 to base 16. So leave your answers in the comment section. We will basically do the corrections there. So your steps can look like this, obviously, if you're doing long division, but do indicate that your number 1 is that, your number 2 is that, and your number 3 is basically that. So you do have to indicate the steps that you're taking, and yeah, as if you're teaching the person what to do. I think it's quite safe now to do decimal to octal. Just looking for examples that I don't seem to have. Oh, yeah. I don't have examples for the octal system. So, but let's say you had 2, 3, 1, 8, sorry, decimal. So 10. So that's a 10, and asked to convert it to a base 8. Right, so what you do the old things that we were doing. So you go 8 here, and then 2, 3, 1. I think I did have some examples. Just already in this book. Probably didn't write them in this book. I think I did. And I created text, but I'm not sure if I should. I'm really not sure. Okay. Let's try. Okay, try this example on your own. Don't want to give wrong answers because I didn't prepare myself, but do try this example on your own, and then let me show you how you would do others, right? So if you have had 1, 1, 5, 6, 10, and you were asked to convert it to octal or base 8. So if obviously they say base 8, you have to know that it's an octal. What you're going to do is do your old whole. Then you have 8. Ask yourself, how many times does 8 go into 11? And then you'd find out it's 1. 8 times 1 is 8. Ooh, okay. So 8, 1, 1, 5, 6. Then we said it's ones. Then we had 8 here. And then 11 minus 8 is 3. Bring down the 5. And then you ask yourselves, how many times that does 8 go into 35? Say 4 times. You have 32. So I'm going to show you how I do it. But obviously, you do have to watch the other recording. Bring down the 8, the 6. So now you have 5 minus 2. That is 3 and 6. How many times does 8 go into 36? You get that it's 4 times, and it's still 32, right? And your answer here is 4. Then let's do the second one right here. So you would have 1, 4, 4, and then the 8. Ask yourselves again, how many times does 8 go into 14? Once. and then that's 8. 14 minus 8 is 6. Bring down the 4. 8 into 64 is 8 times, and that's 64. And that's a lot. And then you'd have so from that you learn that 1 1 5 6 10 is the same as 2 2 0 4 8. And then I'm just gonna leave you with examples to try on your own. So try doing 9 9 10 to a base 8 number. Yeah, and then I think that's it. Next time we're going to do things like converting, using all these conversions and everything that we've learned. I don't really like using the simple methods because for me, it's more like it's actually quite a lot of work. Even though it makes it shorter, it is quite a lot of work for me. So I just leave it to what it is. Thank you so much for joining. Please do leave a like, subscribe, and then hop onto the next video where I teach how to do the jumping conversions from this to that. And then also I'm gonna upload a video on long division because you do have to quite know all the divisions. And I'm gonna post a video also on the bases. So how to move from what base to maybe 8 base 0. No, sorry. Um, base 8 to the power 0, or the base 16 to the power 0, and the base 2 to the power 0, and up to infinity, but obviously not up to infinity, but up to a certain degree. We do have to know all of those conversions and how to divide too. So yeah, thank you so much for joining, and that's it from me.